Welcome again, dear grade 10 students, and in this slide we are going to know about trigonometric functions in the right triangle. So as you know, since grade 10, whenever you have a right triangle, as you see here, this is a right angle at A, and this is angle theta corresponding to the vertex C, then all what you have to recall is that in this right triangle, sine of this angle theta is equal to the measurement of the opposite side to it over the measurement or divided by the measurement of the hypotenuse. So here you have sine theta is equal to AB over BC. So the opposite side to theta is AB. Cosine theta is equal to the adjacent side to this angle other than the hypotenuse, and here it is AC, divided also by the measurement of the hypotenuse, which is BC, and thus it is here AC over BC. Tangent theta is equal to the measurement of the opposite side, this is the opposite side to theta, divided by that of the adjacent side, which is AB over AC. Now you have also that tangent theta is equal to sine theta over cosine theta. So if you divide these two together, you will cancel BC with BC to get AB over AC, as you see here. So if you have found sine theta and cosine theta and the question was to deduce tangent theta, then you divide sine theta by cosine theta, the results you got above. Okay? But if you don't have such questions, so you can directly use the measurement of the opposite side over the measurement of the adjacent side. Now notice that because in the right triangle, the largest or the longest side is the hypotenuse, then definitely sine theta and cosine theta must be less than 1. Okay? So sine theta and cosine theta are always values that are less than 1. Now let's continue to see what we have also about sine and cosine. Let's see here the trigonometric circle. Notice that, and let's recall by definition at the beginning of this chapter we said that cosine of the angle theta is equal to the abscissa of the angle A, of the point A. Okay, so cosine theta is equal to the abscissa of the point A. So this measurement from here to here represents cosine theta. And sine theta is equal to the ordinate of this point A. So this measurement here that's indeed equal to this measurement here represents sine theta. And we know that the radius, notice, the radius here of this circle represents the hypotenuse if we consider this right triangle. So the same rules mentioned before previously, sine theta is equal to the opposite over the hypotenuse. Cosine theta, which is this value or this measurement, is also equal to the adjacent over the hypotenuse. And here the hypotenuse is 1. So this measurement alone is equal to sine theta, and this measurement alone is equal to cosine theta. Okay, now using similar triangles and ratio of similarity and so on, we will notice that and discover that tangent of angle theta is equal to sine theta over cosine theta, which is the opposite over the adjacent to theta. And here you notice also that a sine theta and cosine theta are definitely less than 1 because the maximum value of the radius is 1, and cosine theta can go from here to here. And now in the other slides we are going to see that not only sine and cosine theta are less than 1, they are going to be bounded in the interval -1, 1. So the value of sine theta are going to be bounded or belonging to this interval, because here we have on the orthonormal system here is -1 and here is 1, here is -1 and here is 1. Then later we are going to notice this rule, but in case we have it in this quadrant only, then sine and cosine are bounded between 0 and 1. They are positives in this case. And we are going to talk about such stuff in later videos, inshallah. And here is like a link that you are going to visit later. I'm going to add it later in order to take more ideas about the trigonometric circle and sine, cosine, and tangent along this trigonometric circle.